Okay, sorry. So, I'm present here now. So, thanks a lot for being there. Thanks that I can help my talk there. What I want to do today is I want to present a CAD package for TCL. Last year, I presented a refactoring project about rattleCAD, and a part of this was isolation of a few packages, and one of these packages, I call it now CAD for TCL. So what I want to do today is I want to show you a little bit of rattleCAD itself, how it works as a CAD software. I want to introduce you the requirements on a CAD software so that we can follow the requirements for a specific library for that. And then I want to dive into the challenges that came up when doing this. So the first step is, what is the software for? I'm a little bit of a bicycle enthusiastic, and what I did in the last, I think in 2004, I did a course for bicycle frame building, and I did something wrong, I think. I was less on building bicycle frames, I did it more virtually, and the product and the result was something like this. In the meantime, I wanted to build it. It was time to build a new frame, but missing of a garage and a workshop, I found someone who is building me a frame. And what I did so far for that is, and that shows the aim of rattleCAD, I was at a bike fitter, and he has two good eyes, and he's looking at my position on my bicycle, and he found out the best position for me. And what we saw there was something like a graphic with the main dimensions, and the next step is go into rattleCAD. rattleCAD is a parameterized CAD system. You can add and you can edit different dimensions, and at the end you get a definition of a bicycle frame or of a bicycle that fits your needs. So when I go to this design step, as a result, I do also some 3D checks. There's an interface to FreeCAD where I can build up a 3D model out of this 2D rattleCAD. And at the end, when this configuration was okay for me, I signed this and get the confirmation of my frame builder, which is Andrea. He's sitting in Milano in Italy, and he will build me this bike, and hopefully I will get it in the next 1.5 months. At the end, it should look like a little, no, that's the wrong one. It's too fast, sorry. Backwards, backwards. Yeah, it should look like this, what you can see on the bottom right corner. What I also can do is, or what I also did is handling the color scheme. And this is more a creative job. It's less like CAD defining. It's more a creative job. What I can do is export the graphic out of rattleCAD as in an SVG file. And SVG is an open standard. You can use it in CorelDRAW, Adobe Illustrator, Inkscape, however. But the SVG file, the SVG standard, will be one important thing we will talk about in the next minutes. Yeah, so far on the images on the bottom right side, from your side, yeah, you can see I should use more time on my bicycle than do some programming, but however. Yeah, I will introduce you the software. That was the preparation I did. So I will take a seat just for a minute and take my glasses. This is the software. And what I can do there is, as you could see, I can scale the image. I can...
Have a look at it.
Ah, sorry. Thanks. No blind state, please. Yeah? Okay. So I cannot see it here. Excuse me this. It's not that easy. So I can use it without my glasses. What I can do there, you could, as you saw at the first image, I have a wireframe model in the background, and what I can do there is change a dimension. You see an event there. There is an edit window, and I can put in something. I can do it also manually. I can change the parameter and enter this. It should update the graphic. That's one point. Maybe it's a little bit easier to see it here. If it makes sense, that's another point. What happens? The graphic changes. To have a good view, I set it back to a default view. So what I can do there is I can do some scaling. I can pan this, and what I can also do there is, this is from the wireframe, the switch to the more engineering frame, so I can select also with events there. I get an edit window, and I can edit dimensions maybe on the tubes. So I have events on dimensions and an object. That's interesting for the frame builder, maybe not that for us. Maybe afterwards we can talk about this. Yeah, a lot of checkups, and at the end, a mock-up, a first view, and a ready bicycle. Maybe if you are a frame builder for your customer, to get a look on it, how it will look like, does it fit to your ideas, what do you think about it? And what also important here is I can change some graphic elements. So this is one handlebar, and I can use another one by double click. So this is done by SVG files that are in a background library available. So this is the SVG once again. So, and what I can also do is export as HTML or as a PDF. So far. Yeah, so I let it for the first. So what have I here? Yeah. So for the requirements of this library, zooming is relevant, panning is relevant, handling events is relevant. A library consisting of SVG is an important part, and yeah, export files in different formats. So mainly in standard formats that are useful and common in the moment. And what's also necessary, if I create some plugins, I don't want to care about this graphic stuff anymore. That should be done by this library and not anymore in rattleCAD itself. rattleCAD itself is for the bike model and all what depends on this, but the graphic library is an own library. And my decision from the last year was, if it's possible to isolate it from rattleCAD, make it free and open, and that's the reason why I'm here now, to present this and do some advertising for this library. Yeah, it's one component out of the package diagram in rattleCAD. So what was the challenge to do this? The main requirements for a CAD library is, so one of the most important things is that the origin is in the bottom left, not on the bottom top. For the creative formats, like for SVG, the standard is on the bottom right, I think, top right, sorry. But I use it for CAD stuff on the bottom left. That's also one challenge because of the TK canvas has it on the top left, and also top left is, yeah, this side, yeah. Okay, and from your perspective, and also the TkPath has it in the same position. So this library has to handle this on the one thing. The other thing is that I want to define default scales, which are not supported by the TK canvas. I want to have the span and the zooming. I want to have dimensions there. and supporting different file formats. Last year, we was talking about the TK canvas, and from my opinion, the most missing part of the TK canvas is that there's no anti-aliasing is available. So when the discussion came up, why don't you use TkPath? And it was one of the reasons to isolate this library. And this library deals with both libraries, as the CAD-application library deals both with the TK canvas and the TkPath. It just depends on if this TkPath is available and if you want it. So it's the same library, it's the same interface. So if you can make it run with the TK canvas, it will also run with the TkPath. Yeah, another point for the TkPath was the fully support for the path element of the SVG. This path element contains the Bezier curves, and it also supports clipping elements. Like you can see it on the right side, this red circle with this zigzag. Yeah, where you can look through to the yellow rectangle. So this was a reason to isolate this package. So and now the next challenging stuff for me. So no, not this. No, that's the other one. Yeah, keep that. For me, yeah. So once again, this should be a power show of CAD for TCL. What you can see there is it supports one format, A5 or A4. It also can work with just use the full space of the frame you place it in. Then there was the support of circles and also on arcs. And yeah, that is a specific thing. The next thing is it supports drafting frames. So if you have a DIN format, a standard format, it's possible to create a frame fitting to this format. And it can read SVG elements, and I think this is the common TkPath. And you can load it into this this canvas. The next point is you can see it in the TK canvas. No, that's not what we wanted to show. Scale minus. On the canvas, the standard canvas, you have the pixelation of the graphics, of course, because no anti-aliasing, and it looks. That's this one, and I can import a file from a sample. This is one specific part because SVGs are handled differently for the TK canvas and the TkPath. So these SVG files have to be prepared for use. And this is okay if you provide for your application an own library. So you can prepare these SVG files yourself as a preparation step. Or on the other hand, you have to use an additional library, and this will follow afterwards, which prepares SVG files for the use in the canvases. But just to show it for the first, here it is, and I can drag it and drop it however I want, and I can zoom and scaling. So this is the first. I want to show you the second one is The second one is the feature of different dimensions. So I have 3 types of dimensions. I have, so where do I see them? Yeah, I can dimension angles, of course. I can have a dimension for a radius, or I can have it for length dimensions, so aligned for 2 points, horizontally, vertically, or perpendicular to one or the other line. And I can change this as a test script. Yeah. Using this CAD-for-TCL library makes it easy to write this test script, because all of the graphic stuff is done by the library, and the script itself is nearly simple. So for the next step, the next important point is to provide this feature, this package, is also to provide some documentation. And in this case, I have some kind of running documentation, which are some test scripts. And one of the simplest test scripts I want to show you here is it's a simple script, and it's doing something like that. So the script itself is, so here is, it requires the package, of course. Then this is a parameter for defining use the TkPath or the TK canvas. It's a simple switch. The creation of the object is like this. You create a new canvas, define the location, define the size, the format, the scale, and the border in your frame where you use it. You can get back the canvas scale, and what to mention here too, this implementation of the CAD-for-TCL package is done with TCL00, of course. Makes it easier to handle some exceptions for me. So what we can see there, so get here. These are buttons, and these buttons are customized with some features, and I just introduce you the features, the procedures for that. So to fit the board, just get a command, and it just deals with the object and fit it. Scale the board, create some content, and what you can see there, these are some examples in an easy way. You just have to define the object, create a drafting frame or a circle, and it's always the same syntax you use. The first one is a list, which is the position or are the positioning options of the shape you use. This will be simple for an oval. These are the rectangle containing the oval, creating a rectangle, creating a polygon, a polyline, line, a center line, which is different from its display. You can create some vector text. So, and before I go too deep into this, I will show you that. You can create some content that's in this script. This script has, as you can see there, no, doesn't work for me. Yeah, 300 lines for showing this. And yeah, I can export this as an SVG file, and SVG files could be read in every standard web browser, maybe for Firefox and so on. So it's easy to share with others. Okay, so once back to our presentation. No. Yeah, okay. So this is what I have shown you before. Yeah, and the next step is prepare your SVG file for use in a TkCanvas or in the TkPath. SVG is a standard, and it contains, or it has a lot of options how to define the same thing. And for the CAD for TCL, I decided to keep it simple as possible, and therefore I do something like simplify the SVG file. So in the SVG file, I have transform features. So if I have a structured node from different groups and the shape at the end, and I can position on every group different information, style information, transform information. And what I did is sum up all this and put everything of them into the final shape. But the first what I want to show you is how to deal with the path element. It's not the big issue if you work on, you use CAD for TCL with the TkPath, because there is a full support of this. It's, I think, and it's a real feature of this library. Currently, for the TkCanvas, you're not able to show the path element or the content of the path element. What I did so far here is I split up the path element in its different shapes. So you can see all of them. So when you look on the first image above, that's the standard visualization and rendering maybe of the file on the right side in Firefox. So it looks like that's the standard and the standard behavior, how to visualize this. For TkPath, all you can see there is that the definitions of the shape is changed a little bit, but not that much. And on the path type, for the TkCanvas, you can see that this path element is redefined as a group, and it contains 2 polygons. These are the 2 definitions of the 2 shapes from the path element. What you cannot do there, of course, is to represent a clipping element. But you can get the content of the shape in your file and in your display, and if it's necessary for you, you can work on the SVG file and do some stuff to make it in any way work for your software where you use CAD for TCL. The next what I mentioned is to use the transform element, which is also defined in different ways. So I sum up all these transform attributes and compute it up as far as to the original shape, and it's computed directly into the shape. So there's no transform information necessary anymore, so that makes it easier. And I haven't tested it, but I think it makes it also more performant when you read this SVG file in the CAD for TCL than you read the native file, where you have to do this conversation before. Yeah, and when you take a look on the polygon definition, which is a representation of the rectangle above, all the transform information is in this polygon, and the transform attribute is not required anymore. And the same with the style definitions. All of the information is at the end summed up in the final shape. Yeah. And how to convert this? This is the second part. For this, I have a second package. It's called SVGDOM. The main feature now, maybe it will get more features in the future, but the main feature now is to reduce a native SVG file for the use inside of CAD for TCL. You can do this on the command line, as you can see it here. Define an input file, define an SVGDOM object, put into this this input file into this object and define the type, in this case for use in the path version of CAD-for-TCL, and then get back the converted SVG file, write it into a file, and you can read this new SVG file in your CAD-for-TCL library in package. And yeah, to show you what is possible to do with this CAD-for-TCL and this SVGDOM library, I want to show you something special. So, I think everyone knows this one. It's the standard graph, and it is possible to display this one in the TK canvas. This is in the default defined as a list of path elements, and converting this one makes a ready canvas, a ready SVG file for use in the TK canvas. So hopefully my process chain is working in this way. Yeah. Do we have enough space? So this is one important thing, or there was one important thing for me when I created all the libraries for the rattleCAD software. I need a toolchain to get, or to convert a file I created maybe in CorelDRAW, created an SVG file, and then have to compute it down to a readable and simple as possible file for the library. What I can do there, and that is the point I want to show you, you don't have to do it in the command line. There's also an interface, a graphic interface available for that. You can read a file, and maybe this is this tiger. It needs a little bit of time. Yeah, and what you can see there, this is the source structure of the SVG file. You have a lot of, so do I have the right one? No, that's already converted, sorry. Or I have to, I wanted to show you this one, sorry, this one. So, this is the SVG file with the path elements. This is the text file, of course. And what's necessary for the CAD software is to have one specific point to locate your file. The standard part is in SVG you have a view box, and this defines, that will be okay, and it defines the area which is shown. To make it easier for me was to define a specific element that defines the origin of this SVG file. And in this case, I prepared it and put a circle into this graphic. I can select it and I can set it as a center. And what happens there is that it adds a new node there, and this defines the position of the new graph, the new graphic. Yeah, that's so far from this side. And we see I'm a bit out of time, so therefore go through. I have a few class diagrams for everyone of you who is interested in maybe support developing. These class diagrams are available on the websites. One's for SVGDOM and the other one for CAD-for-TCL. This is the address on the bottom. This was the wish list from last year. Maybe there's an own discussion about this. Yeah, and I think, Yeah, what I have shown you is the rattleCAD as a software, the CAD for TCL library, the SVGDOM library, the web URLs. So if you're interested, take a look into it. And yeah, that's from my side. Thanks a lot for watching, and so I'm open for some questions.
I would have liked to see if the gradient in the tiger picture would be visible in the TK canvas.
Yeah, it's a little bit a lack of time, and what I have to do there, this is the rendering stuff normally is done in the canvas itself. So when I prepare it in a step before, in the front of step, then I have to define it myself. So for the path and the TkPath is not the issue, but of course it is an issue for visualization in the canvas. Yeah, of course.
I really don't know.
It's
so it would not the gradient where the tiger has a gradient between orange and white. Would that have been visible, or is it solved somehow?
The gradients in the tiger SVG is done with different shapes.
It's separate.
They're separated there. So there's no. Yeah, I think that was a solution for that. I don't know how old this file is, but this is done there with different shapes.
Discrete path.
Yeah. It looks smooth, but it is not. Yeah. Okay. Yeah.
I have three short questions. First, you mentioned you create PDF files.
Yeah.
Do you use an external library, or do you do it by yourself?
No, I use PDF for TCL, of course.
Okay. Then which source of TkPath you are using? There are different repositories.
Yeah, that's an important issue, of course. It's a little bit kind of pain. Yeah. I had some some issues defining or displaying the center line, which is a dotted line, and I had a bug with the current version so far.
But which version you are using?
Currently, I use a version of Christian. So once again, thanks a lot for supporting me in this. The maintaining of the TkPath libraries.
I know it.
Yeah, okay.
And the last question is, how do you deal with rotated text in the canvas?
Currently, I keep it simple. I use an own font for that. It's a vector font, and it's not the standard font, so the problem is not that big in the moment for me. Yeah, but it would be a problem if I use the standard fonts, yeah, of course.
Okay. Thank you.
I think what stays in rotated fonts, just use them.
Yeah.
No fonts.
Yeah, for the further development and the next steps, I think I will take care on this. Okay. So if then, yeah.
Last question on your wish list from last year. Are there some wishes for TkPath left?
Yeah, what I did so far was to extract the library as it worked for rattleCAD. So all my main issues are into this library now. I didn't took a look over the border what's necessary for the next steps, but I think there would be some. I think all what you can see there, all this zooming via creating a rectangle, this panning, also creating events. This is done currently by standard TCL scripts. And this stuff could be inside the TkPath. Also what I wish there would maybe something like, I didn't dive into TkPath that much, but also what I wish to have is to have a scaling, a standard scaling would be fine. So I don't want to care about that myself. I just want to use this library. And what I did there is, to do some ways around to make it work in any way. So for you in the moment, as a user of CAD-4DCL, you don't care, it works, hopefully. And for the future development, it would be fine if it will be in the TkPath. And on the other hand, I wish to have TkPath in the standard TK, TCL and TK. That's what I want to have. Okay, so far, thanks a lot.